Earlier this year, a biotech company announced it had done something scientists said was impossible. They brought back the dire wolf, a predator that's been extinct for 10,000 years, the apex hunter of the Ice Age, the animal that stalked mammoths and giant ground sloths across a continent we wouldn't recognize. It's back. Except it isn't. And the gap between those two sentences is one of the most disturbing things happening in science right now. Because what Colossal Biosciences created isn't really a dire wolf. It looks like one. It was engineered to look like one. The skull shape, the coat, the body mass, all designed from a 72,000-year-old fossil. But genetically, biologically, it's something that has never existed before on Earth, and that raises a question that's going to bother you for the rest of this video. If we rebuild something from scratch, is it the same thing we lost? Before we get into what Colossal built, let's talk about what we actually lost. The dire wolf, Enochion, was real, genuinely, terrifyingly real. It roamed North and South America for hundreds of thousands of years. Bigger than any wolf alive today. Heavier. Built differently. Stockier legs, a wider skull, a bite force that could crush bone the way you'd crush a cracker. Fossil evidence suggests they hunted in packs, coordinating to bring down the giants of the Pleistocene. Giant ground sloths, young mammoths, horses the size of modern draft breeds. The world they lived in was a different planet. North America full of megafauna that makes our modern wildlife look like a petting zoo. And then, roughly 10,000 years ago, they were gone. The Ice Age ended, their prey collapsed, and within a geologically short window, every single dire wolf on Earth was dead. What we had left were bones, tens of thousands of fossils, more than almost any other Ice Age predator, preserved in the La Brea tar pits in Los Angeles. Skulls, leg bones, teeth, an overwhelming archive of something magnificent that we arrived too late to see. But before we get to the resurrection, there's a twist in the fossil record itself that almost nobody knows. In 2021, scientists finally managed to sequence ancient DNA from dire wolf specimens. And what they found changed everything we thought we understood about this animal. The dire wolf wasn't closely related to grey wolves at all. Their evolutionary lineages diverged roughly 5.7 million years ago, before modern wolves even existed as a species. The genetic distance was so large that researchers reclassified them into a completely separate genus. Enochion, not Canis. In other words, the dire wolf wasn't a big wolf. It just looked like one. Evolution, working independently on two separate lineages, produced a strikingly similar shape for similar reasons. A large pack predator in a prey-rich landscape. They were strangers wearing a familiar face. Hold on to that phrase. It matters more than you think. So here's what Colossal Biosciences actually did. They took the genome of a dire wolf, sequenced from a 13,000-year-old tooth and a 72,000-year-old skull, and compared it, letter by letter, against the genome of the grey wolf. They identified 14 key genetic regions where the species differed in ways that affected physical appearance. Then they used gene editing to make 20 precise changes to living grey wolf DNA, targeting the instructions for skull shape, body mass, coat color, and jaw structure. Think of it like editing a book. The grey wolf's genome is roughly 2.4 billion letters long. Colossal found the specific sentences that differed from the dire wolf's version and rewrote them. 20 edits, out of 2.4 billion. The result? 3 pups, born across 2 separate births in 2025 and 2026. Romulus, Remus, and Khaleesi. White-furred, broad-headed, built as far as the fossil record can tell us, like the animal from the Ice Age. They are genuinely beautiful, and looking at them, it's hard not to feel like something was actually returned. But here's where the math gets uncomfortable. 20 edits out of 2.4 billion letters means Romulus, Remus, and Khaleesi are, by volume, overwhelmingly grey wolf. Their internal organs, grey wolf. Their immune system, grey wolf. Their nervous system, their hormonal architecture, their instincts, their vocalizations, their ability to navigate social hierarchies, all built on a grey wolf foundation. And remember what we learned in the last section. The real dire wolf wasn't a grey wolf at all. It diverged from that lineage 5.7 million years ago. The genetic distance between an actual dire wolf and a grey wolf is enormous, and Colossal's edits barely touched it. So when Colossal says they brought back the dire wolf, what they really mean is they built a grey wolf that looks like the fossil record, which is extraordinary and deeply strange, and raises a question that philosophers have been arguing about for 2,000 years. There's an ancient thought experiment called the Ship of Theseus. The story goes, Theseus had a great ship. Over time, every plank rotted and was replaced, sail by sail, board by board, until eventually nothing of the original material remained. Every atom of the ship had been swapped out for something new. Is it still the Ship of Theseus? Philosophers have argued about this for over 2,000 years, and now, thanks to Colossal Biosciences, it's no longer just a thought experiment. It's a real animal standing in an enclosure in the Colossal Preserve. The dire wolf had a genome, a complete ancient genetic identity built over millions of years of evolution. We took a different animal's genome and edited 20 sections of it to produce a similar physical result. The body says dire wolf. The DNA says grey wolf with modifications. The fossil record says neither is actually Enosian dirus. So what did we make? There are 3 ways to think about this, and I'm going to give you all 3 because I genuinely don't think there's a right answer. Framework 1, the functional proxy. By this view, what matters isn't the genetic sequence. What matters is the ecological role. Colossal built an animal that fills the same physical niche as the dire wolf, same size, same build, potentially the same behavior. If it hunts like a dire wolf and looks like a dire wolf and affects its ecosystem the way a dire wolf would, then for all practical purposes, the dire wolf is back. The genome is an implementation detail. Framework 2, the biological ghost. By this view, Colossal built a tribute, a sophisticated, beautifully engineered tribute, but a tribute, the animal that actually lived, that actually evolved, that carried millions of years of genuine evolutionary history, that's still gone. What we have now is a grey wolf wearing the dire wolf's silhouette as a mask, an echo, a ghost that looks real but isn't. Framework 3, a new species entirely. By this view, and this is the one I find most interesting, Colossal didn't bring something back at all. They created something that has never existed before in the history of life on Earth. Not a dire wolf, not a grey wolf, a synthetic species. A first draft of a new kind of biology, where extinct animals serve as blueprints for completely new creatures. By this framing, we shouldn't call it de-extinction. We should call it what it is, creation. 3 frameworks, same 3 animals. Which one is true? Here's the thing. The dire wolf isn't Colossal's destination. It's their business card. The company has active projects to de-extinct the woolly mammoth, the thylacine, the Tasmanian tiger, and the dodo. And the argument for doing so, at least for the mammoth, is more serious than most people realize. The woolly mammoth project is built around a climate hypothesis. For tens of thousands of years, mammoths and their relatives maintained what scientists call the mammoth steppe, a vast grassland ecosystem across Siberia that reflected sunlight and, crucially, kept the permafrost frozen. Frozen permafrost sequesters enormous quantities of carbon. Thawing permafrost releases it. The theory goes, return large grazing animals to the Siberian tundra, and they'll trample the snow, compact the soil, and slow the permafrost thaw. Colossal's mammoth, which will be like the dire wolf, a modified Asian elephant, rather than a true resurrection, might function as a climate intervention. Whether that works is genuinely uncertain. But the reasoning is serious science, not just novelty. And the same philosophical question follows every animal in the pipeline. What exactly are we bringing back? A species or a costume? And here's what should make you sit up. This is all getting much faster. Until recently, gene editing was powerful but slow. CRISPR, the technology that made headlines a decade ago, could make precise single-gene edits, but editing whole biological systems was laborious and error-prone. In 2025, researchers at MIT identified a new system called TIGR, transposon integrated gene reconstructor. Unlike CRISPR, TIGR can integrate entire sections of DNA in a single operation. Not one sentence rewritten at a time, whole chapters swapped simultaneously, 1,000 times faster in early modeling tests. If CRISPR was a scalpel, TIGR is a word processor for genomes. The mammoth, the thylacine, the dodo, Colossal's entire pipeline just got dramatically shorter. Which means the questions we've been asking about the dire wolf are questions we need to answer soon. Because the next announcement isn't years away. There's an objection to de-extinction that doesn't get enough airtime. The dire wolf evolved for a world that no longer exists. It co-evolved alongside giant ground sloths, short-faced bears, American mastodons, horses the size of heavy draft breeds. Every element of its ecology, its prey, its competitors, its parasites, its place in the food web, is gone. The ecosystem it was built for has been extinct for 10,000 years. So when Colossal talks about returning the dire wolf, returning it to what? The American landscape of 2025 is not the American landscape of 10,000 BCE. The prey is different. The vegetation is different. The climate is different. The other apex predators are different. What you'd actually be doing is releasing a powerful, novel predator into an ecosystem it has never encountered. From a strict ecological standpoint, that's not restoration. It's closer to introduction, which is exactly what conservationists spend decades trying to prevent. The Mammoth Project, at least, has an ecological argument built in. The dire wolf, as of now, does not. And then there's the question nobody wants to ask. Romulus, Remus, and Khaleesi didn't ask to exist. They were engineered, created as proof of concept by a private company. They live in a controlled research environment, monitored as demonstration animals for technology that is, at its core, designed to attract investment. What do we owe them? This question is becoming more pressing across biology. At Northwestern University, researchers have grown human brain organoids, clusters of neurons derived from stem cells that produce synchronized electrical rhythms resembling early human brain development. As these technologies mature, the line between experiment and entity with interests gets harder to define. We are building things that may feel. We don't always know what they feel, and we are moving fast. The 3 pups in Colossal's enclosure are alive. Whatever they are, proxy, ghost, or new species, they experience the world. They have preferences. They form attachments. They can suffer. That's not a footnote. That's the whole point. Here's what I actually think. What Colossal did is genuinely extraordinary, not because they brought back the dire wolf, I don't think they did, but because of what the achievement actually demonstrates. They proved that we can take genetic instructions from a 72,000-year-old skull, translate them into a living, breathing animal, and have that animal walk around in the world. That has never happened before in the history of life on Earth. That is a real and remarkable thing. But the framing matters enormously. De-extinction is, at best, imprecise. What Colossal is actually doing, and I say this with genuine admiration, not cynicism, is writing new species. They are using extinct animals as design specifications to create synthetic life that has never previously existed. That's not resurrection. That's creation. And we should talk about it with that level of honesty, because what we call something shapes how we think about our obligations to it. De-extinction sounds like undoing a mistake. Creating a new species sounds like making a choice. We're making a choice. We are currently losing species at roughly 1,000 times the natural background extinction rate. Some estimates put us in the early stages of a 6th mass extinction, caused almost entirely by us. Against that backdrop, the technology Colossal is developing isn't just a curiosity. It's a question about what kind of relationship humanity wants to have with the living world going forward. Do we accept that what we destroy is gone forever? Do we use synthetic biology to rebuild what we lost, knowing the rebuilding is imperfect? Do we create new species to fill ecological roles that nature can no longer fill on its own? None of those are easy answers. And anyone who tells you they are isn't taking the question seriously. Romulus, Remus, and Khaleesi are alive. They are the first of something. And the decisions we make about what they are, proxy, ghost, or new species, will shape every decision that follows. The mammoth, the thylacine, whatever comes after that. We brought something back, or we built something new. And maybe that question is the most important thing we need to figure out. So I want to know where you land. Functional proxy, biological ghost, or new species. Which framing do you think actually fits what Colossal made? And the harder question, should we be doing this at all? Leave it below. There's no right answer. That's exactly what makes this so hard and so worth arguing about. Thanks for watching. And stay curious. Subscribe for new stories, new discoveries every week.